Hi, I'm Fred, your personal assistant. I sure like being inside this fancy computer.
When I started this project, I thought it would be pretty quick to pull together, and I had no idea it would take over 6 months to complete and take a completely different turn from what I set out to do. This is how it all started. When I grew up, I was a little bit of a nerd. Well, to be fair, I still am. All my friends had computers like the Commodore 64 or even Amigas that were super cool for playing games. But my parents, they had a Macintosh Plus, which was more of a work computer. There were some really good games on that too, but it didn't even have, a color screen. So I wanted to build my own computer games, and that's how I started programming. And I started in this program called HyperCard, which had a very easy programming language called HyperTalk. You could write something with just a few lines of code. Couldn't really build any fancy games with it, but it was a great starting point for experimenting and learning. As a kid, I also watched all these movies of the time. One was War Games. The story was about a guy basically hacking into different systems and playing around with them. He accidentally got into this military computer, but this was like a really cool artificial intelligence that could actually talk.
How can it talk? It's not a real voice. This box just interprets signals from the computer and turns them into sound. Shall we play a game? Oh.
I wanted to make the computer talk itself. At that time, that wasn't really an option. The best sort of chat program was called Eliza. And the only thing it did is took everything you wrote and it rephrased it as a question. So it was, I guess, a little bit like a shrink. But fast forward to today, now it's actually possible to do. So I wanted to pay a tribute to my childhood and to the old Macintosh I started learning coding on and built just an awesome project. Interestingly enough, when Steve Jobs revealed the very first Macintosh in 1984, it actually spoke. And just listen to how amazed they were by this.
Today, for the first time ever, I'd like to let Macintosh speak for itself.
Hello, I am Macintosh. It sure is great to get out of that bag. And accustomed as I am to public speaking, I'd like to share with you a action I thought of the first time I made an IBM mainframe. Never trust a computer you can't with. Obviously I can talk, but right now I'd like to sit back and listen. So it is with considerable pride that I introduce a man who's been like a father to me, Steve Jobs.
Two years later, Apple released the Macintosh Plus, which was a big deal because it had a whopping 1 megabyte of memory. The original Mac only had 128 kilobytes. So imagine all the stuff you could do with this new computer. The one we had even had a hard drive with 20 megabytes of storage. That was just incredible at that time. So what was the plan I had here? Originally, I wanted to find an old Macintosh Plus and just have it in my apartment because it looks so cool. But I figured I don't really have space for it. Then I found that you can build these miniature ones powered by a Raspberry Pi. So I thought that I could build one of those and have it turn into a voice assistant. That way, I both get to have that nostalgia of having the old Macintosh, but it's also something new, a cool project. It would be really fun to build a UI for it, and it could actually be useful. I thought that this way, I could actually realize my childhood dream of building a talking computer. It shouldn't be too hard now with all the ChatGPTs and generative AI. I was the man with a plan. So, how do we put all this together? Well, I have a little bit of a plan. I was thinking first we get the Raspberry Pi to run the Open Voice operating system, which is basically turning it into an Alexa. And for that we need a speaker, we need a microphone, we need the Raspberry Pi, and optionally, I think a screen, so it can show some stuff on the screen, I think. But the plan is to replace the visual UI with basically making it look like it's speaking, so we'll have a face on the Macintosh, a little bit like the icon when it boots up. I thought that I had all the technical details figured out, just puzzle the pieces together. And I was thinking that we can listen to the events and voice operating system, give us a stream of things happening. I'm thinking of piping that through Serverpod, which is a backend framework in Dart language that Flutter is using. Basically, Serverpod to listen to events from the open operating system, patch that to our Flutter app, add authentication, multiple giants listening app for it, not just running on the Raspberry Pi, but So I ordered everything I needed for this project. I found this really cool 3D printed miniature version of a Macintosh Plus, which I ordered from Etsy. I ordered a Raspberry Pi, a screen, a microphone, and a speaker. I got the first initial things. I think we need to start building this. I'm still waiting for the actual case, which will be 3D printed. But let's see what we can do with the parts we have. And I think the goal for today is to get the voice assistant up and running, just as it is, and then we can start looking at adding more stuff to it. I'm a big fan of making things work and then start adding stuff to it rather than trying to build everything at once. All right, let's unbox this and see what we got. We're starting with a Raspberry Pi starter kits. We have here Raspberry Pi case, probably not going to need that one. We have the power supply, we have the Raspberry Pi, and let's see, we also have HDMI cable and very important, memory card. Let's check the speaker. I got this like super cheap ones, so if they don't work, we may need to find another solution, but we'll see. Hopefully they'll just plug and play. Curious to see what this looks like. All right, this is our USB speaker, and here we have the microphone. And the screen, I'm also curious to see. It's a very small screen, but it will be a very small computer, so that matches. Danger zone. Don't play with scissors, kids. All right. Let's see what we got. All right. This is the screen. So it will be a very, very tiny Macintosh we're building. All right. Let's see if we can plug this together. First thing we need to do is to get an operating system onto a Raspberry Pi. And we'll store it on this tiny little memory card, which has 128 gigabytes of memory. Fun fact, it's like more than 6,000 times the memory of that huge hard drive I had as a kid. There seem to be quite a few ways we can get our OpenVoice OS onto a Raspberry Pi. The easiest seems to be to just use the Raspberry Pi imager and burn an image. So I read through the documentation here. I have downloaded OVOS, the OpenVoice OS for English, pre-configured. And now we're opening the Raspberry Pi imager, and should be possible to use a custom image from your computer. So here I'm going to choose the file I just downloaded, and we can do some configurations. So we are going to set the host name. We're going to call it Fred, because that is the name of the original Mac OS voice. And I'm thinking it would be pretty cool, that's sort of a stretch goal, to see if we can get it to talk with that sort of original Mac voice. We'll see. We will enable SSH so that we can connect to the computer. Since we don't have a screen, it would be very useful. And we are, let's see, use password authentication. It looks good. Let's use the username Victor. Okay, and I will pick a password. And we're going to configure our wireless LAN. Play sound when finished. All right, let's try this out. Choose storage. Well, we got the one there, and then we are going to start writing it. Let's see how this plays out. All right, we are back. I got some lunch and a good coffee and am good to go. So I have plugged in the memory card into the Raspberry Pi. I have also plugged it into the electricity and plugged in the microphone and the speaker. So the first thing we're going to try is to see if I can connect to it. And we named it Fred.local. So we should be able to connect with SSH straight away through our Wi-Fi, because it should know our Wi-Fi password from the installation. So let's give this a try. We are going to do SSH-L for the user login, which was Victor. And then it's Fred.local. Let's see. This looks promising. It's asking us for our password. So let's enter that. And we are in. Awesome. So let's see. We got some tools here. It says we have the ovos config, ovos listen, ovos speak phrase. Maybe we'll try that first. See if we can get it to speak. Ovos speak. Hello world. Oh, okay. That did not work so well. Connection refused. Is message bus service running? Probably not. To be honest, this doesn't feel quite like plug and play. All right, I feel like we're a little bit on the wrong track here. Maybe we need to start this somehow. Let's scroll up and see if we have any clues. Maybe it was update. Python definitely installed. All right, let's do the ovos server status. Did I just break this? Right, looks like nothing is running in here. So do we need to start it? ovos service failed because the control process exited with error code. Failed to start ovos service. Not super helpful. Okay, we got a bit more of a log here, maybe defined by. Right, couldn't get that to work. Not sure what's wrong. I have to say, looking through the installation instructions, a little bit confusing. It says just flash it on there and it should be good to go. Didn't work for me. So I found another way to install it. So I'm going to try that and see if that works better. So basically what we're going to do is just flash a default Raspberry Pi installation on there, and then we're going to run the installer program. I found the guide linked from the download page of all places in the documentation. So let's see if that will work. Yeah, fingers crossed. Let's go. This turned out to take many more tries. I probably flashed that SSD card over 20 times, but I finally managed to figure it out. We are a couple of coffees later and I finally got it working. There were a few things that led me astray here, and the first was that the documentation told me to install that light version of the Raspberry Pi OS, which could have been a good idea, except it doesn't come with a sound system, which seems to be crucial for doing a voice assistant. So I got that installed, and then I installed the OpenVoice OS with a sort of Python installer instead of using that Docker container. I don't know if that makes a difference or not. Maybe both will work equally well, but that's what's working now. So here we are. Hey Mycroft, what time is it?
Currently 5:51.
So there is a little bit of a delay, but maybe that's something we can work on. I'm not quite sure how this actually works, if it's using like an LLM on the Raspberry Pi, but I feel like I'm leaving it in a pretty good state for today, and we will come back tomorrow or a few days later and keep at it and start adding all those more features we want in there.
1 week later.
It's been a week and I made some progress. In fact, I spent the whole day yesterday trying to get that Raspberry Pi working, and I finally cracked it. So I'm very happy with that. I probably flashed that memory card at least 20 times starting over, and every iteration took so much time. But I now got the OpenVoice OS working on it. I got Flutter running. I got the screen working, even works with the touch. And I got a whole bunch of scripts I can use to run it from my Mac, which makes it so much more convenient to work with. And I got this package with the enclosure for the voice assistant. So I am super excited to open that. Maybe that's what we should start with here. So let's go see what this looks like. I couldn't be more curious. I'm like a little kid at Christmas. Whoops. All right, let's see what we have here. It's pretty well packaged. And so it's 3D printed, but I have to say, I mean, it's so cute, and the quality of the print really looks good. I'm not really a big fan of the layering style you get from 3D prints, but this is so smooth. So actually looks really cute. Let's see what else we have here. I think that is the little disk drive for it. So let's see if I can open this up. All right, so I'm not going to mount the Raspberry Pi here because chances are I'll have to reflash that drive at least another couple of times before this is all said and done. But I mean, this looks great. I can't wait to put this together. Little did I know that it would take me many months to get back to this project. Spring turned to summer and summer turned to fall. Because life as a startup founder is busy, and summer is for spending time out in the sun, going sailing, working out and backpacking. The Mini Mac sat in my closet for a long time, but it wasn't forgotten. In fact, a completely new idea for the project began to grow in my mind. It's been a while, but I think I am finally ready to wrap up this project. And I have a completely new plan. I really like to take care of my plants and repot them and make them thrive. But one problem I have is that it's really hard to know when to give them water and how much. In the past, I tried to solve this by getting these sticks, and I really like the idea of them. You put them in the pots, and if the plant needs water, they go white, and if there's enough water in the pot, they stay blue. But these have two problems. The first problem is that they're really expensive, and the second problem is that they do not work at all. Or some of them work for like a month, and then they either stayed blue all the time, which is probably the most dangerous thing to happen with them, or they are stayed white. So, piece of crap. But I found these other guys on a cheap Chinese site. So these are electronic plant monitors that basically is a soil moisture sensor. Look like this. And you put them in a plant, they have battery, they use the Zigbee protocol, so I can have them talk with my Home Assistant. And then my plan is to connect my little mini Mac to my Home Assistant, pull all the data from all of my sensors that I put in the plants, and I can get these nice graphs, see when I need to give them water. Pretty cool idea. So this is the new direction for the project. Let's go. I decided to implement this with Flutter and Serverpod. What's so great about Flutter is that it runs on almost anything. You can run it on your iPhone or Android, but it also runs on desktop computers and even my Raspberry Pi. Actually, I don't understand why Raspberry doesn't promote Flutter as the default UI library, because the developer experience is so much better than anything else. In addition to using Flutter, I used Serverpod for the backend part of the app. It fits perfectly with Flutter and allows you to write everything in the same computer language. It's also great to run a small server on the Raspberry Pi, because then I can also connect to it from my phone, in case I'm not right by the Mac Mini. I pretty much vibe coded the whole thing. I would never do it for something important, but for small stuff like this, it can be pretty awesome. If you want to learn more about vibe coding Flutter and Serverpod, I've made a video about that too. I'll link to it in the description. My plant monitor ended up turning out great. I've connected all the sensors to my Home Assistant. The Serverpod inside the Mini Mac connects to it and pulls all the data from the last 2 weeks. Then Serverpod streams all the updates to the Flutter app that is showing the UI. The UI displays a card with a little graph of the moisture level of each plant. If the moisture level goes down below a certain threshold, the card will turn red, so I can immediately see if a plant needs water. I can quickly adjust the level for each plant. I love my new plant monitor system, but I feel like I can't quite leave it here without seeing that initial idea, see what it would look like having that Mac talk. So I'm just going to take some time, build it out, and let's see what it looks like. So I took another evening and just coded it out. I did the facial animations in Rive and exported them. Unfortunately, as it turns out, for some incomprehensible reason, Rive has chosen to write parts of the playback engine in C++, and I couldn't get it running on the Raspberry. I almost gave up at this point, but I finally coded up a little app that would export animations as PNG images. Then it was simply a matter of playing back the voice, having my app analyze the audio levels, and selecting an appropriate image to display. And I couldn't be happier about how it turned out. Before I show you what it looks like, I'll do a quick shameless plug. If you want to build your own personal assistant, now is the time, because Serverpod is launching a hackathon called Build Your Flutter Butler with Serverpod. There are $20,000 worth of prizes. How awesome is that? Anyway, I'll let Fred, my personal assistant, wrap up this video.
Thank you for watching. Make sure to subscribe so that you don't miss any of Victor's upcoming projects. He builds a lot of cool stuff. Until next time. Bye.